Hello everybody, this is our video for problem 4 from my spring 2020 final exam. This is related to the previous video in that it is also going to be using the first fundamental theorem of calculus. Only this time we're using it in reverse, in the sense that we're trying to find an antiderivative rather than computing a derivative. So here we're given a function, tangent of 3 minus e to the xt, and we want to find an antiderivative, and we are not going to have much luck if we try to use the usual techniques, integration by parts or integration by partial fractions or substitution, etc. But the first fundamental theorem of calculus will make this very easy. Now I'm going to work through this very quickly and show you the answer, but stay tuned to the end where I'm going to show you one of the big notational mistakes people make and try to explain why it's so silly. So let's see here. What would be an antiderivative? Well, let's recall quickly. I call it FTOC 1, the first fundamental theorem of calculus. That tells us if we take the derivative with respect to x of a function defined from c to x, and say we have some function f of t dt, then this derivative is equal to f of x. All right. Now, what this tells you in words is that the integral from c to x of f of t dt is an antiderivative of f of x. Why is that? Well, what did it mean to be an antiderivative, right? Well, you're an antiderivative for a particular function if when you take the derivative, you get back that particular function. So I take the derivative of this expression, this function of x, and I get f of x. So this must be an antiderivative for f of x. So my goal in the end is to find an antiderivative, well, for this function, this f of x. Well, there it is, right? So all I have to do is say that the integral from, well, let's say 0 to x tangent of 3 minus e to the x squared. Except we want a t now, right? We're on the inside of this integral, and we're going to integrate with respect to t. This, by FTOC 1, by the first fundamental theorem of calculus, is an antiderivative of tangent of 3 minus e to the x squared. Because if you take the derivative of this expression, you get tangent of 3 minus x squared. That's it. That's the whole solution, right? Now, a lot of people are going to try to make this a lot harder than it is. They're going to try using techniques. They're going to get this, and then they want to just do stuff with it. But no, we've solved the problem. Now, there's a very common way of writing down the solution that is just nonsense. Let me quickly do it. I'm going to do it in red, right? Remember, we want to dread the red. So, how do people write this wrong? How do people get this wrong? So the question here, right, is about finding an antiderivative for this function. Now we know that the solution is this. Okay, but here's the most common way people get this wrong. They're going to write down tangent 3 minus e to the x squared equals the integral from 0 to x tangent 3 minus e to the x squared dt. Now this is a very different statement. Up here we were saying that this integral is an antiderivative. Here we're using the equal sign. We're saying these two functions are equal. All right. This would be like saying, I know that an antiderivative for x squared is x cubed over 3, and then writing this equals, or rather, x squared equals x cubed over 3. Of course, this is nonsense, right? It doesn't. Okay, this would be the same thing as somebody saying, oh, what's the derivative of x squared? Oh, it's 2x, and then writing x squared equals 2x. Of course it doesn't, right? So these are nonsense. Nonsense. Now, what does this mean? Well, this means to get this right, you can't just be thinking that this is an antiderivative. You actually have to say it, right? You can't just write that these things are equal, because they're not. You need to write a derivative, right? Of course, we could put a derivative with respect to x out front, then they would be equal. All right, so work on that notation. Make sure that what you're thinking and what you're writing are the same thing.